Hello, everyone. I'm Severin from DFINITY. I work on the SDK team. Maybe a couple of you already know me from the forum. Helping people on the forum is one of my favorite ways of procrastinating. So yeah, if you've seen my face before, that's probably where. Let's get started on cross-chain governance. I'm holding this workshop relatively high level because there's a lot of different ways you can do cross-chain governance or even interpret the term cross-chain governance. So I'll stay a bit high level, talk you through how to set up things a bit, but then please ask a lot of questions about your specific cases. I think that's way more useful than me just picking one or two specific ways how to do it. So maybe first, why do you want to use ICP for cross-chain governance? There's a couple of reasons besides you just liking it more. First one is it's cheap. For example, the demo project I'll be pulling up a couple of times, I developed that directly on mainnet for maybe a week or so. I made a lot of calls to other chains, and during an entire week, it cost me about $1 worth of gas. It's fast. We have 2-second finality for the most basic transactions. If you call out to other canisters or even other chains, of course, then you're gonna accumulate some delays, but small transactions are very fast, and that's very convenient for voting on a lot of different things. Another big selling point that the Internet Computer has is timers. On most other chains, transactions can only happen if someone actually calls into the chain from the outside. On the Internet Computer, there are timers that work kind of like cron. They're not quite guaranteed to run at the very second you set them up to run, but they're good enough for most use cases. Another pretty cool thing is decentralized front ends. So you can even have your website where everyone votes fully decentralized and vote for updates to those websites. So everyone gets the same capabilities at the same time. There's no advantages between people using different tools for voting. And then also really cool, as you'll see, in many cases, you don't need any bridge contracts. If you get into advanced cross-chain things, you still may need them, but for a hackathon, most of the time you should be good to go without a bridge contract. When I sat down to write the slides, I thought, yeah, maybe we'll talk about voting and how that works. But then I thought, wait a second, there's more to governance, and I'm sure some of you will want to do some different things. So I'm going to define governance as you decide what to do with one or more people. I put one person in there because that can also be an interesting problem to solve. We use some predefined process, so we keep the decision-making process relatively static. And then we also want to act on it, because otherwise, if you don't do anything with your decisions, there's not much purpose to governing things. So going to the first line, you want to decide across one or more people. There are, depending on your situation that you want to use governance for, you run into a lot of different problems or questions. The easiest case, I'm not saying it's easy, but the easiest case is a single user system. The super stereotypical application for that is a wallet. If you use a wallet, or if you build a wallet, you probably care about keeping access to it, so having multiple means of accessing the wallet. You want to make it easy to manage assets, but you don't need to think about making decisions because it's just a single person that has access. If they want to do something, they're allowed to. Of course, you can make that a bit more complex and want to allow some automation on that, for example, and then you want to give those automated tools only access to certain things. So maybe you want to do some permission-based access. But yeah, it's relatively simple in terms of making decisions. Then a bit more complicated, you have multi-user systems, but you know who or at least how many people you have. That's more for a kind of trusted situation. For example, you have like a small group of people working together on a project and not wanting one person to be able to screw over everyone else. Or you have, like in a company where you have someone trying to do something, but they need approval, but it's a relatively controlled setting. But there you have a huge amount of flexibility in how you make decisions. A lot of you will be familiar with multi-sig wallets, meaning more than one person needs to approve of something. There's ways you can do voting, where you just have one vote per user, or you can give someone with, you can give some people more weight in the vote and some less. You can even come up with other things like you're just gonna automatically do whatever anyone wants to, but everyone is allowed to veto other people's actions. I'm sure you guys can come up with a lot more fancy mechanisms, but yeah, don't be scared to try things. We have a very flexible system here, and technically code can do anything, so why not try to do it? Permission management, maybe you want to have someone, maybe you want to do the same as in a single user system where people can log in through different methods, but often you will not think about that too much because you just use some identity provider like Internet Identity or Christopher Sive or Plug Wallet, something like that. And then last, what's probably the thing everyone thinks about first is a multi-user system where you have many people. People change a lot, but typically if people have some tokens around a project and you want to make people have votes depending on their tokens they have. But again, it's not as simple as just taking the account balance because there's ways to, depending on how you program things, there may be ways to use the same tokens to vote multiple times, or you want to say you only want people to be able to vote if they actually explicitly stake some tokens. Yeah, so it's also not quite trivial in that case. The code that I have linked everywhere and that we'll have a look at does voting by account balance. And I guess if you don't want to think too much about governance, that's the simplest way to go. Right. To do something a bit more practical than just me talking about stuff, I have an example here about balance-based voting, since I'm guessing that's what most of you would do if you do governance across multiple chains. The really important thing with balance-based voting is that you need to take a snapshot at some point in time. Otherwise, someone votes, and then they transfer their tokens to a different account, and then they use that account to vote again, and they transfer the tokens to a third account, and they vote with the same tokens once again, and then you can throw away the whole governance system because it doesn't work. On a lot of EVM chains, you just have the block height that you can pin your queries to, and that makes the whole thing pretty trivial to handle. At the point in time where the proposal gets submitted, you just check what's the current block height, and then you always query balances against that block height, and you're safe to go. I'm doing this in this small demo project, but there's different ways you can do it. There's even services that allow snapshotting. You can mirror all transactions of a project to the internet computer if you want to go that way, because you think it will save you some resources. And I'm sure you can come up with other schemes as well. And the second point that you really need to think about in balance-based voting is that you need to translate somehow between the user and the account balance. Often that's pretty simple, but depending on the scheme you want to do, you have to first think of how you want to get to whatever balance the user has that is valid to vote. So with all that talking out of the way, let's have a look. I'm here in the project that I link on every slide. It is a demo project, basically. It's mostly geared at hackathons because focus in the code is on making it easy to read and simple to copy paste from. It doesn't do error handling at all in many cases, but it shows you how you can do things and how to get things working quickly. As with every internet computer project, you have a DFX JSON that defines what is actually in the project. Here you can see it uses Christopher Sive to sign in with Ethereum because it talks to Ethereum, or while developing most of the time to Sepolia, which is an ETH testnet. Then we have the backend canister where we look at most of this workshop. There is a front end, but I won't touch that today, I guess. And then we use the RPC canister, which you've heard about yesterday, I think, from Gregory, if I'm not mistaken. It also contains a very simple ETH contract that just stores the last 10 strings that got submitted to it, just so I can show how to connect, or just to demo that the connection works. I'm not an ETH guy. I don't know much Solidity, so I just made a simple thing that shows things work. In the backend, lib.rs is the main place where magic happens in terms of defining logic. Here you can see the function submit proposal. We have execute proposal. We have submit vote here. And then there's ethrpc.rs. I put together this file mostly so you can just copy paste it and forget about most of the implementation details. It has a function to submit an ETH transaction, so you don't have to think about signing a transaction because the canister does it for you. It sends it automatically to the EVM RPC canister, There is the ETH call function that does not a transaction, but just a read state. There's a couple utility functions that are quite convenient to have. And you can get, you can make ERC20 transfers, you can get ERC20 balances directly. These are probably very useful to get a starting point where you can copy paste together to build a nicer, bigger transaction out of. But let's have a look at lib. Let me just double check what I wanted to actually talk about. Yes, balance-based voting and submitting proposals. So here's the function that gets called when you try to submit a proposal. We first translate with Christopher Sive, the caller, to the ETH address. So we can display which ETH user actually made the proposal. We do some error checking. And then here, very important, we get the latest block number from ETH. Again, popping over to the ETH RPC file, so you don't have to think too much about it. But here we do a request to the RPC canister that checks what's the ETH block number. We can then, in every of the balance functions, use that block number to make sure we include that number here, so we don't get the double vote problem that I talked about earlier. We then save the proposal with a lot of the parameters that you want to define yourself. Yeah, submitter or submitter ETH address, that's just a matter of taste if you want to include it. We initialize to 0 votes, and we remember the block height. And then here, when you vote on a proposal, again, a lot of error handling. Then you translate whoever tries to vote to the ETH address. Check if the person hasn't voted already. And then we fetch the voting power. In this case, I'm using the ETH balance because I didn't feel like setting up an ERC20 contract, because it was already enough of a hassle to get Sepolia ETH, but you can easily switch that over to ERC20 balance. And then, depending on the voting power, you just increase the votes. Or if you want to do quadratic voting, you can do that. If you want to say if you have a stake of at least 10, then your vote counts as just 1 vote. Yeah, there, your fantasy is the limit. Let's see. This would be a great place for a first round of questions, if you have any. I expect a lot of you didn't see something they wanted to see, or I skipped over some details somewhere that you think I really should know more about that. Let's give it a couple seconds.
Yeah, feel free to write your questions in the chat or in the questions tab down below, right next to the chat. Let's give it maybe 30 seconds with a short break until, and then if there are no questions, we can proceed, I think.
Then I'll use that time to also copy paste the link to the repo in the chat. Okay. Either I did a great job at explaining everything or no one understood anything.
It's the first. It's probably the former, yes.
Okay. Let's pop back into the presentation. Yes, correct button. So now that we have a vote or a way to create proposals and sort of safely vote on them, we have to do something, or at some point a decision is made. There's a couple common schemes of how we decide when to act. The two very obvious ones are when you get an absolute majority or just based on a timer. For the absolute majority, you need to know what's the max amount of votes or the total supply of the tokens or how many people are even allowed to vote. Often that's pretty trivial to get, but if you want to execute the proposal as soon as possible, when there's no way for the result to be something else, you need to think about how you can decide on when that point in time actually happens. The big thing that can trip people up with this is if you do early execution of votes or proposals, it can result in surprising orders of execution. On the internet computer, we have this problem occasionally, and it's pretty annoying if you don't absolutely control when the vote goes over the threshold. So just to make it easy on yourself, I would suggest not using this option if you want to be able to move very quickly, because dependencies pop up in surprising places all the time. Then we get to one of, at least in my opinion, the big selling points of the internet computer. That's timer-based. Canisters can run cron-like timers, so you can tell the canister to wake up in 2 hours from now, or 20 seconds from now, or 2 days from now, or even every 30 seconds or every 2 hours. And it's a very powerful thing to have. There are even Oracle services on other chains that simulate those timers, but those are very expensive in many cases because running a transaction on something like ETH is pretty expensive if you want to do it every 30 seconds. If you decide on proposals based on a timer, you get a determined order of execution. That is very nice, but it takes a bit longer to get to the result usually because you want to give people a generous amount of time to vote, but then you always have to wait until that time period has passed. Then if you want to have the best of both worlds, you make a combination. So there, if you get an absolute majority, you execute the proposal early. Otherwise, you just wait until the proposal or until you've given it enough time. The NNS does something like this. For those that don't know, the NNS, that's the big DAO that governs the whole internet computer. It executes proposals either when an absolute majority is reached, or after 4 days, or if the vote is very close and whichever side has an advantage over the other, if that switches regularly, then it will extend the voting period of a proposal, just so that no one can ever say the decision was made because the timer ran out. It's a very cool system, but relatively hard to implement in a hackathon when you're stressed for time. But if you want to develop your product a lot more, I think that's a very nice way to do it. Let's have a quick peek at how this works in the demo project, because there's 2-3 small things you need to think about when using timers. So our demo project does it really simply. We have a timer that runs every, let me check, every minute. And every minute, this timer checks if any of the proposals should be executed. This happens by every proposal having a field that says, after this point in time, if we check the next time, we want to execute the proposal. I think that's probably the quickest way to get a timer-based execution done. 2 things you need to keep in mind here. First is you have to set the timer in init and in post-upgrade. On the internet computer, you can change the code that's running in your canister. But for that, all the state needs to be written to disk and then reloaded. And whatever is in the heap gets thrown away. And which timers are running or which timers are set up is also considered part of the heap in this case. So in post-upgrade, you have to reset all timers you have. If you don't use a single global timer and instead a timer for every proposal, you need to set a timer for every proposal again. It's not too big of a deal. It's done pretty quickly if you think about it. If you forget about it, it can lead to lots of annoying bug hunts because you're thinking about why did this timer not fire? It's probably just because you didn't set it. Then the second thing that can happen if you use a low timer interval, it is possible. So canisters on the internet computer are single-threaded. So you cannot have multiple updates happening in parallel. But if one call pauses or awaits a response from a call, a different update can sneak in between, and then you can interleave parts of updates. This is usually not a problem, but if you have a low timer interval and proposal execution takes a while, it can happen that the timer fires while a proposal still gets executed. Make sure that you set your proposal as getting executed before you do the first await. Otherwise, you build your own re-entrancy attack. And for example, transfers will happen multiple times. We just had this very problem in a project we demoed last week at a conference. And it looks pretty stupid if you say, hey, it's going to transfer 10 tokens, and then 20 tokens show up in the target account. Question about timers or when to execute votes? It's pretty simple. I don't expect anything, but now is a good time to ask.
Yeah, it looks like someone is typing, so let's give them a second. Yeah, we did.
Yep,
It
I've
seems
looked
like
at it a few times.
we all have. That's the whole point. But yeah, looks like no questions on timers right now.
Okay.
Yeah, Jill is asking if you could go into multi-chain DAOs a little bit. How would the governance work with multi-chain DAOs?
Yeah, I can't tell you much because it's all up to you to define. So yeah, I can show you how the tools work. Yeah, things like Chainlink, those, yeah, they just pass information from one chain to the other, or they hold tokens on one chain in one place for another contract. It's all based on how this system exactly works. I'm showing you here how you can think about it or how you can get started with it. But it's all how you want to implement it. I think you need to ask something more specific.
Maybe
since this is not quite connected to timers, I'll continue and get back.
Yeah, let's do that, and then we can swing back at the end.
I don't have too much more, so I'm sure we'll have plenty of time to discuss that. Then the last big part is how do you want to act? So you now have this, made a proposal, you decided on what the result is. Now, how do you want to act? That depends a lot on what the proposal is supposed to do. Again, Chainlink as an example, you can use that for a lot of different things. On ICP, it's pretty simple. We have a lot of examples how to call other canisters or other functions on your own canister. Transferring tokens is super simple now that we have the ICRC 1 or 2 standards. For those in ETH land, the ICRC 1 and 2 standards are like ERC 20 equivalents. On ICP, you can even update a front end, or you can update a canister. If you folks are interested, I can show you how to update a front end afterwards. It's not quite trivial, but it's not that hard. So it's certainly doable in a hackathon. For other chains, you can call functions, you can transfer tokens. You guys probably know even better or much better than I do what is possible through all those RPC calls. I know on ETH there's a typical architecture for updatable smart contracts, even though they're immutable in principle. Yeah, here the sky is the limit. It's just code. It's just calling functions. The big problem with other chains is how do you pay for those transactions? A canister on the internet computer, it can hold its own assets on other chains because it has a private key that can sign transactions. But to execute those transactions, you somehow have to pay gas for it. On the internet computer, this is not a problem because we have reverse gas where the target contract pays for computation. But on ETH, on Bitcoin, on basically any other chain, you have to give your smart contract or your canister some gas to work with. Often that's just a problem of economic incentives, or you can just say we as the founders, we sponsor those transactions for a while and then hope we find something better at some point in the future. For a hackathon, that's certainly fine to do. But I know this is a big problem for many projects. So start thinking about it early enough. Also, small implementation detail. I can show you the code for that afterwards, how to figure out the account ID of your canister. But if you just use a local DFX instance or Internet Computer Replica instance, that can already execute transactions on other chains. That's no problem. But if you restart your replica and you wipe the state, then the next time you will get a different private key, meaning if you had funds in that account, they're now gone. Because of that, I suggest you do most of the multi-chain stuff directly on chain, either test in production or have a second test instance running, so you can always keep the same accounts. It makes your life so much easier. I don't think I could have built my small demo in a couple of days if I ran it locally. And then this may be a bit surprising for a chain fusion hackathon, but you can also perform actions off-chain. It's a bit harder to do, but it's possible. You can, for example, use a trusted person to act on behalf of your canister. I heard, please don't quote me on that, but I heard there is a way in Liechtenstein for a DAO to execute actions in the real world through the use of a lawyer. I haven't checked how that legally works, but there's ways to do that. The other, probably more foolproof solution is to use economic incentives. For example, if someone has to do something off-chain, for example, training an AI model or taking a picture of something, you can then either vote on some evidence if that is worthy of distributing a reward, or you can even use some way for them to submit, for example, a zero-knowledge proof that they performed the task, and then unlock some reward for them this way. Again, I'm sure you all have a bunch of great ideas how to do that, but don't be shy to use that, even though it sounds a bit weird at first. Yeah, that's the theory I got. Let's do Q&A, office hour style.
Perfect. Okay, do we have any questions? Let's give it a sec to answer. And until then, I'll ask a very standard question, which is, I think, a very appropriate question for this this workshop, since it's a hackathon after all. What kind of project would you like to see built with cross-chain governance if one decides to go into that general direction?
Is that directed at me?
Yes, that's
or chat. Okay. Let's see. So I know there's a bit of a hole for something like a multi-sig wallet for use in companies, where people can use small amounts of tokens just on their own. At some point, it requires approvals, role-based access control to those different resources. It's not that sexy of a product, I guess, but I know the need for that is there. If you end up doing something with votes based on tokens, I think if you could do something more interesting than just whatever your balance is, that's your votes, I would really like to see that. To me, how many tokens you have, that's how many votes you get. That's just boring at this point. But it's a hackathon. You want to do the other things. I get it.
Yeah, exactly. I mean, everybody has their own creative ideas, and the point of Hackathon not just to show coding skills, but to show how good of an idea you can come up with in general. We have a couple of questions. Thomas asked, you said you could show updating the front end in the canister. That would be very helpful if you could quickly go into that as well.
Yes, so just wiping the state. Let's show updating a front end. I'm just showing you the parts you need to know. I don't have a full big demo setup, but this is good enough. I'm just deploying the demo project that you get if you do DFX new. So just our Hello World example. It has a minimal backend that basically echoes your input back and a very minimal front end. Just running DFX deploy usually updates the front end automatically, as you can see here. If we now change the front end, you can see I was very creative earlier. Okay, now we change the front end. Now we can do deploy with the by proposal flag. This means we will upload our whole change set to the canister and then lock it in place. And then people can vote on if those changes should be accepted or rejected. The DAO can then decide if they want to accept it or not, and in a single function call, perform those changes or not. The reason why we have this is because transactions are relatively limited on the internet computer. Relatively limited meaning you can at most put in 2 megabytes of data per update call. And for a lot of front ends, you have a lot of different assets or just a website that amounts to, I don't know, a couple dozen megabytes. And putting all those changes through a vote is just way too tedious. The governance canister can then call the commit proposed batch function on the front end. And for that, it needs a batch ID. Here we had batch number 2. And the hash of this whole change set. And if then the governance system calls this function, then the changes get applied to the canister. Now, the front-end canister has a permission, what's it called? A role-based permission system. So you can give different principals, different permissions on the canister. The uploader, whoever uploads those changes, needs the prepare permissions, and whoever wants to be able to accept or reject those changes needs commit permissions. If you have a look at the candid file, the interface of the canister, I can show this over here. It's not that hard to find, to figure out how to do it. The front end here. So DFX always puts files in .dfx and then the network name. And here we go to canister's front end and then the candid file. Here we have the different permission levels. And here's the grant permission function and the revoke permission function. On internetcomputer.org, we also have documentation about how this exactly works. With a search function, it should be pretty easy to find. Then Kartikeya, multisig sounds doable. DM with questions later. Yes, you can absolutely DM me afterwards. I think the easiest way to DM me is on the forum. This is my user profile. I don't think there's much I can tell you that no one else can tell you, but happy to help out. How to upgrade the backend that's controlled by the governance canister. No, the backend, you can update that with a directly with a function call by the governance canister. You don't need to prepare anything in advance. Updating a contract is just a call to the management canister. That's the AAAA-AA canister to the install code function. I'll show you where you can find the documentation for that, I guess. We've been in Rust land here, so wait. I'm forgetting the names. You can just use this function in your canister directly. The argument, the mode that says if you want to upgrade or reinstall the canister, then of course you have to say which canister you target, and then you need the new code, and optionally some arguments. You can just use an empty vec if you don't have any installation arguments.
Cool. Looks like we have one more final question coming from Artem. Just typing right now. Kritika says, thanks, I'm right in the ecosystem. I'm not aware of the voids in the ecosystem, so help would be great. Perfect.
Another great way to find some voids is grants program, either the one by DFINITY, which you can find here. There's, if you scroll down a little bit, you can find the focus areas. Those are the places where DFINITY thinks the biggest holes in the ecosystem are. Another great place to find open problems is the forum that I just linked to with my username. If you search for open bounties, mostly by the user, how do you pronounce that? Skillser. It's Austin. Let me get his username. This user posts a lot of bounties on the forum as well. Those are certainly worthy projects as well. I think those are often a bit smaller than the ones by DFINITY, but I'm sure both are great places to get inspiration.
Yeah, very good resource indeed. Artem just asked, is it possible to securely save signature on existing PK using multisig or somehow secure deal with external PKs?
So just to clarify the question, are you saying you cannot use something like Christopher Sive or other things like that? Or what exactly do you mean? So in general, you just need to validate the signature in a canister. There's most often just ready-made libraries that you can just reuse in your canister. And then you usually just present a challenge from the canister that the user then has to sign. And then if that signature is valid, you just use that as the user ID.
Let's see what Artem says. Cool. Until then, we have a couple of more minutes left. So if you have any final questions, everybody, now's the time to ask them because we'll be wrapping up soon.
I think I'm not quite understanding your question, but how to do web calls from ICP? You can just directly use the HTTP request method. The Internet Computer just can do HTTP calls by itself. And we have a bunch of examples on how to do that. I'll link you the examples repo for that. Here's the example for a simple GET request. I don't quite understand how you connect that to other public keys.
Cool. Yeah, then I think that's pretty much it. We're mostly out of time. Thank you everybody else for coming. Thank you to Severin for coming and doing the workshop. Any final words for the audience?
Was great having you all here. I hope you can see why the Internet Computer is very convenient to use, and I'd love to have you here in the ecosystem. If you have more questions, or Artem, if you maybe want to clarify again, let me just copy my username again for the forum. We can continue the conversation over there. Yeah, it was great having you all here.
Yeah, having great. It was great having you as well. Until then, everybody, my colleague Yasin will be in touch regarding your projects. And good luck. We can't wait to see what you build for the hackathon. Thank you very much once again, everybody, and see you around. Bye bye.